Example is built on the previous example. So again, Bernoulli example. And in this case, you have the same jet of water, let's say, water coming into, so this is water coming in, being injected into a pool of oil. Okay, this is raw oil, and this is this water has density raw water. So let's say this jet kind of does something like this before it starts breaking up, and then there's oil surrounding it. So the situation over here is a little bit different compared to the previous example. And again, we're asking the question, what is the jet diameter over here at a height h? So the situation here is a little bit different. Previously, we were able to neglect to assume that the pressures at station 1 and station 2 for the Bernoulli equation are equal. In this case, that's not the case. Because since this water is being immersed in the pool of oil, then the following must hold, that P at station 1 must be equal to the pressure in the oil, and P at station 2 must be equal to the pressure at station 2 in the oil. So the relation is that P2 at station 2, P at station 2 is equal to P at station 1 plus rho oil G times H. Okay? Or you could say that P1 is equal to P oil, which is rho G H oil, H above the oil, and then take the difference. So this gives you rho oil GH. Okay? So now we can apply Bernoulli and say P1 over rho water plus V1 squared over 2 plus GZ1, so again, this is Z, okay, is equal to P2 over rho water plus V2 squared over 2 plus GZ2. Now, P1 and P2 are related by this formula, so we get, let's take everything to the left, we have P1 minus P2 over rho water plus V1 squared over 2 plus Z1 minus Z2, that's GH, equal V2 squared over 2. Remember, we are after V2 because mass conservation tells us that A1 V1 is equal to A2 V2, and V1 can be computed. Let's say this is connected to a tank, or we know what the velocity V1 is. So what we're after is essentially the area A2, which is V1 over V2 A1, and we want to calculate V2 from the Bernoulli equation. So now what is P1 minus P2? So P1 minus P2 is minus rho oil GH, so that gives us minus rho oil GH over rho water plus GH plus V1 squared over 2 equal V2 squared over 2. So now we combine these two guys and we get 1 minus rho oil over rho water, okay, times GH plus V1 squared over 2 is equal to V2 squared over 2. So that gives you V2 squared equal to 2 times 1 minus rho oil over rho water GH plus V1 squared. Then you can plug this guy back into the area to find the diameter at the height H.